a logical connection between the two DTE equipments, which is the end devices, over a packet switch network. So when it is creating a logical connection for communication, it supports a bidirectional communication between the DTE devices. Yes, and then in this virtual circuits, we have two categories, switched virtual circuits and the permanent virtual circuits, SVCs and PVCs. First, about the switched virtual circuits. So this is a temporary connection when there are some irregular data transfer between the DTE devices. So in that case, it's called as a switched virtual circuits, and this includes the call setup, data transfer, idle, and the call termination. These are the processes involved in this particular links. And coming to the second category, which is the permanent virtual circuits, as the name tells, yes, since we have some frequent and consistent data transfer in that particular link, we can have a permanent virtual circuits. So the frame relay network supports permanent virtual circuits as well. So every time there is no data connection and termination every time. So it is available and there can be data transfer and an idle state. Moving on to the congestion control mechanism supported by the frame relay, there are two categories, FECN and BECN, forward explicit congestion notification, backward explicit congestion notification. First, the forward explicit congestion notification. Forward, from the name itself, we can say this is been when the data transmission is started or when it is forwarded, the DTE only forwards the data. That is will be a sender, it forwards the data. So it is initiated when the frame is being sent from a DTE device. So when the frame reaches the destination, so that can understand that some congestion has happened in the network. That indications will be there in the frame. So with that it can be understood and flow control can be initiated. Otherwise it can be ignored also. So that is the forward explicit congestion notification. The opposite of that is the backward explicit congestion notification. The DC devices will be setting the congestion value. So it is setting the BCN bit to 1. And so when it is returning back, the receiving DTE device will understand that some congestion has happened in the network. So in this case also, based on the BEC and bit indication, either they can initiate the flow control or it can be ignored also. Then frame relay discard eligibility bit. So the DE bit is it's like assigning some priority to some frames. So this, if a frame contains this DE bit, then it becomes a very least prioritized frame. So whenever some congestion happened, so some devices may try to discard the overloaded frames. At that time, they will discard the frames which are having this DE bit. Discard eligibility. It will give the discard eligibility to a frame. So, which means assigning some least priority to a frame with the help of discard eligibility bit. Then frame relay error checking. So here the error checking mechanism is achieved with the help of the CRC, cyclic redundancy check value. So it calculates the value to determine, it will calculate the known state and the current value and then compare so that it can verify whether the data is error, um, data has some error or not. Then coming to the implementation of the frame relay network, as we have seen, the devices in the frame relay network contains the DTE and the DCE devices, which will be connected to the remote ports on a multiplexer equipment. And also this is done through a point-to-point service. So this picture tells the frame relay network. At the end, you will have the router, or it can be called as a frame relay interface, and that has been connected to a multiplexer device, and which helps the WAN connectivity, which gets connected to the WAN connectivity. So this is the frame relay network picture. Then this frame relay, it can be defined as a public network, or it can be this frame relay network can be utilized as a private network. So first, about the public carrier provider network. So in this case, the frame relay switching equipment